AuroraFS is the first system to enable real-time playback of high-definition videos over peer-to-peer networks. Now, as you know, on the 5th of October, we did launch our testnet and we gave a tutorial on compiling, deploying, and launching a node for HD video playback. So in this video, we'll take a closer look at how to use the dashboard as a tool to learn more about how AuroraFS transfers data over peer-to-peer networks. So first of all, we need to install the dashboard tool. There's detailed installation steps on our website. Process is very simple. Just copy the commands and execute them straight away. Now, before executing the commands, please note it's necessary to modify the node's course allowed origins. Now, this configuration item is empty by default, and make sure to restart the node after the modification. Now, start installing the dashboard. Just follow these instructions. Now, when the dashboard tool is installed, it will prompt the URL addresses of the dashboard. There's two of these addresses. One is the local access address and the other is the access address of another device. Again, it's necessary to modify a node's course allowed origins, and this configuration is empty by default. We can open the dashboard via a browser. So open the browser, here we're using Chrome, and just type in the browser http://local:8000. So at this point, we can see the dashboard. So we're just going to explain the configuration. So select settings, configure the API port, and the default value is 1633. Configure the debug API port, and the default value is 1635. Please note the IP. If a node is not started locally, please replace the local host with the node IP. Otherwise, the connection status will be disconnected. The connection status is connected, which is excellent, and you can move on to the next part of the explanation. Select info to view the details of the start node. Now, connected peers has been interconnected with 16 full nodes. There aren't many nodes in the test network at the moment, so if more people join in, the more nodes you will connect to. Discovered peers has been interconnected with 16 full nodes. Node mode. The startup mode of this node is full node. Our node has two modes, full node and light node. Full nodes can upload, diffuse, and download data, which can be understood as a server-side node. Light nodes only allow downloading data, which can be understood as the client-side node. Light nodes are not interconnected, while full nodes can be interconnected. Full nodes and light nodes can be interconnected. So if you want to learn more about this, please join the community discussion or read the white paper. So next up, select peers. Now, discovered peers has been interconnected with 16 full nodes. Connected full peers and 16 full nodes are interconnected. And connected light peers and 12 light nodes are interconnected. Now we're going to calculate the depth of a node based on the number of full nodes connected to each K bucket. This concept is relatively complex, so please join the community to discuss it further or read the white paper if you're interested. Here's the hash that is connected to the address of full nodes, and here's the hash that is connected to the address of light nodes. The test network currently has 3 files available for everyone to test, downloads in the form of hash values. The information is stored on oracles, that is, the smart contracts of the BSC test network. So we encrypt the files according to the algorithm and cut them into chunks of equal size, and the chunk size is 256K. Select a file hash and click download. The node will get the chunks directly or indirectly through the connected full nodes. Upload hasn't been fully open for the time being. Currently it can be uploaded to this node. If there is a need to download from other nodes, it is required to register in Oracle. This function will be open in the future, so please pay attention to the community information and follow us around. Compared with ordinary downloads, most of the files we download are from HTTP sites or FTP sites. So if many people are downloading at the same time, obviously the speed's going to be much slower due to the server's bandwidth. On the other hand, AuroraFS is different. Now, because we adopt a multi-point to multi-point transmission principle, files exist as hash values. So all you have to do is enter hash values for downloading. The start node will calculate according to the hash values and obtain chunks directly or indirectly through the connected full nodes according to the hash value. So the more people download, the more corresponding servers will be, and the more data will be diffused. And at the end of the day, the faster the download speed will be. The read performance of Aurora is far more efficient than Ethereum Swarm. Although Swarm also uses a multi-point to multi-point transmission, it can't meet the needs of industrial and commercial applications as data is actively diffused and malicious code can store junk data on the network. Junk data is essentially propagated and stored throughout the network, which wastes valuable bandwidth and storage space. Aurora has an on-demand data diffusing scheme. The stored data is automatically diffused to adjacent nodes on demand when it is read frequently, which is convenient for transmission. Data is processed between adjacent nodes when it is not read infrequently, so that the bandwidth and storage space are not wasted. Enter the hash of a HD video. Open the browser and just play it. The playback speed is no different from that of a traditional content distribution network. Now, unlike traditional content distribution networks, the more people play it at the same time in AuroraFS, simply the faster the speed's going to be. We can drag and drop, jump around, and see the effect. So can you feel it? This has no difference with the download and real-time playback of centralized CDNs, and fully meet the needs of industrial and commercial application for the first time ever. So is it still the case that decentralized systems are known for inefficiency and slowness? In fact, peer-to-peer traffic distribution system is not only a substitute for content distribution network systems, but it will far exceed our traditional mechanisms in terms of cost, market size, and economic value brought to the world. Our team members will produce a separate video again to explain this to you. So thanks for watching the video. Make sure to like, share, subscribe, follow us on Twitter, join our Telegram group, and we'll be seeing you around. Bye bye for now.